Happy Sunday. Mm. that that morning croft. I apologize. First words I've spoken today. Happy Monday, everybody. I just noticed my camera is not flipped. I usually like to have my camera flipped. I got a new webcam, um, and so my camera's not flipped. So I like to have it flipped so that I can when I talk about directions or something. So if I say left, it'll go left. Let me see if I can fix that real quick. Um, Filters. Is there a flip? Smab UK. Nice to see you this morning. Happy Sunday, my friend. Hope you've been getting some better rest this weekend. Let's see, where's the... Should be an option here to just flip this, right? Oh, that's so annoying. I wonder why that is. I'm glad you're feeling better rested. I'm trying to... There we go. I'm backwards, but now if I say left, it's left on the screen. And people, it makes it harder for people to read what games I have on my game shelf behind me. I'm glad you're feeling better rested. Yeah, we missed you yesterday. We had Keith yesterday. I wonder why you're not getting notifications. Very peculiar. Dylan Beatty. I don't know who that is. Is that another... I'm assuming it's another streamer, another coder, another programmer. Bring this chat over just in case people get curious. Alright, I'm gonna shrink that down for me here. But yeah, happy to have you here this morning. It's always nice to have people who are our fellow programmers able, especially people who are better than me, able to help me out. Gotcha. So we're doing day 11 today. The Advent of Code 2022. I'm gonna have to check him out. Dylan, I'm gonna add that to my list real quick. Let me steal that name, put it over here in my notes. There we go. I appreciate the recommendation. Yeah. Oh, but didn't actually copy. There we go. Beautiful. Now I got it. We're gonna look at this puzzle day. Yesterday's puzzle was really fun. I'm a huge, whatever. I guess you might call me a compiler nerd or a systems nerd. I like hardware that's simulated. Not that I don't dislike real hardware, but real hardware is hard. It can fail. Software has... One of the things we've engineered in computers is, what do we call it? Correct first computing. In computers, the way we've written software, we can assume that the hardware is going to be correct. And thus, we end up with really easy to reason... Easy is a strong word. Can reason about the logic very well. There's a new type of... it's a little bit different than... This has actually caused us some challenges. And your video on release looked more like my model of a CPU than the solution I did on stream. Yeah, the solution I did on stream... Yeah, my solution on stream was very different. Not very different, but quite a bit different. But yeah, I wanted to... There's a great excuse to model a CPU. I've done that many times, so I thought that would be... So I'm going to make my students do it, so it's a great excuse to be like, oh, here's a CPU. And then I'm probably going to have a project for them next term where they have to extend it to add additional features to it, or maybe some different... So basically add a different model CPU. Let's hop in here. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. That's fascinating that the monkeys can operate on such a condition. You take some notes on the items each monkey currently has, how worried you are about those items, and how the monkey makes decisions based on your worry level. For example, all right, so we have multiple monkeys. These monkeys are very smart, clearly. Starting items 79.98. I'm not 100% sure. Oh, here we go. Monkey has several attributes. Starting items lists your worry level for each of the items is currently holding. Okay, so this is our worry level. It's not like an ID. I thought this was an identifier for an item. I was like, that's interesting. All right, this is our worry level for a specific item. Operation shows how your worry level changes as the monkey inspects an item. Okay, so the monkey is going to inspect an item and it's going to get a new value. Test shows how the monkey uses your worry level to decide where to throw the next item. Okay, so then based on that number, that item's going to go to a different monkey. Okay. Got it. I think each monkey inspects an item. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest. All right, so then we're gonna do integer division, dividing by 3. The monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding one at a time, and in the order listed. Monkey 0 goes first, and then monkey 1, and so on until each monkey has had one turn. The process of each monkey taking a single turn is called a round. All right, so one monkey is going to throw all of their items to wherever they go till they have no items left. Then we go to the next monkey, and it throws all of its items till it has none. Then we go to the next, and I'm assuming. So one round would be all of the monkeys taking a turn, I believe. The process of each monkey taking a turn, yeah. The monkey throws an item to another monkey. The item goes to the end of that list. A monkey that starts around with no items could end up inspecting and throwing. Oh, so at the start of the round they could receive items and then they will process some. Okay. If a monkey is holding no items at the start of its turn ends. Okay. So this is a single round. Monkey 0 does a bunch of work. Throws all the items. All right, so we check divisibility first. Oh, no. We perform our operation, divide by 3, check divisibility, throw. All right. Operation, divide by 3, divisibility, throw. Okay, cool. So after one round, so round 0, the monkey is the input we're getting. Round 1, the start of round 1. Oh, no. After round 1. After round 2, okay. So I think I know how to process a round. Chasing all the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys. You want any hope of getting your stuff back. Count the total number of times each monkey inspects an item. Each monkey inspects items over 20 rounds. Count the total number of times each monkey inspects items. Is this saying inspected an item, or this is how many turns? I think this is how many turns they... It must be, no, because they would get at most 20, so it must be the number of items total that they inspected over the 20 rounds. So we got to track that, select the 2 biggest times. The level of monkey business in this situation can be found by multiplying these together. 101 by 105. What is the level of monkey business after 20 rounds of shenanigans? Stuff slinging simian shenanigans. All right, cool. I think I get it. Before that, though, Smab, I'd love to see your solution to yesterday's. Let's check this out. All right, let's make this a little bit bigger here. What do we got? Okay, so part 1, cycle check start, cycle check interval. Ooh, I like that. I like that. I completely over-engineered it. That puzzle was so fun to me. I just wanted to I wanted to engineer it over. I wanted to get it as over-engineered as possible. I loved yesterday's puzzle. I think that's my favorite one so far. Load instructions. Solution 1. We have a CPU. Oh, this is such a beautiful I loved how nice this is. Execute the program, then get a sum. This I would call this beautiful, elegant, functional-esque code. Coding Cafe, part 2 is your favorite part. That worries me. That worries me. We'll see. We'll see. Thanks for popping in. It's nice to see new people. It's nice to have people watching me code, making me nervous, and telling me what I'm doing wrong. So I appreciate you being here. So let's look at what execute program. Ooh. Execute. Can I jump there? Look at that. Is that a new feature, or have I just never known that? I feel like I've tried that before. Execute program. Okay. Ooh, this is okay, cool. Is this you're using something from a previous? Oh, hang on. Never mind. It jumped me to the wrong place for sure. All right, it has to be down here. Okay, this looks much more normal. Smab, for a second I was thinking you had done some crazy and over-engineering, implementing a whole different CPU model. Here we go. So we started instruction number 0. We do a countdown. Yep. So this is gonna be, I'm assuming, how many cycles we have left to finish an instruction. Yeah. Okay, this is nice. I like that we're using IEnumerable here to give us back the signal strength. That's clever. I really like that. If it is an add X instruction, we add it. And increase the instruction number. Otherwise, we just... Okay. This is nice. I really like this. This feels so... Well, maybe not super clean. I might get a little bit... If I was teaching, I might tell my students not to nest this way. But I was about to say this is super clean if you understand... If you can understand the problem statement. I really like this execute program here. All right, then we got an instruction. This is essentially what I did with mine. An instruction has a command and a value. All right. And then for solution 2, the little CRT display was so fun to me. I loved it. Yeah, I was gonna say, at a glance, I was like, this looks so big, but I think, it felt like just the way it was indented. When you're doing systems level type programming like this too, you end up sometimes just with some weird gnarly looking code anyway. This really isn't that bad. Because we can essentially just get rid of this while loop. Say, well, this while loop isn't real. The real code here is this chunk. This is what's happening. And I'm also zoomed in. That's the other thing. I zoomed in for the stream a little bit, so it's a little easier. But really, this is the logic, and you could you could break this into two logical chunks, and then you always do this. And so what I would probably, if I was telling my students how to organize their code, I'd tell them, oh, we'll break it out into this, and then this, so that way you have, testable chunks. But we don't, one of the things as you get better at programming, this is the thing, my early programmers, I make them break everything down and test every little bit. But as you develop those skills, and you know this, I don't need to tell you this, but as you're developing those skills, your mental model, your brain is capable of just handling more, has a larger bandwidth, a larger cache from practicing, from flexing that, from working out that brain muscle, essentially. So, no, I think your solution is beautiful. I like it a lot. All right. So let's monkey around a little bit. Thank you again for sharing it with me. Awesome. Yeah. Absolutely. Is there an automated, do you know? Let me ask this, because I don't know and I've never looked. Is there an automated testing framework for C#? I love the quick test in Haskell. I remember I always tell students when I started programming. So I didn't start programming until the 90s. I started programming in a language called Quick Basic, not Basic, but Quick Basic. So XUnit has automated. Oh, when you say automated tested, you mean making automated tests. So you like handwrite tests. I was thinking, so Haskell has something called Quick Test, where it will, based on your types, it's able to generate tests for you. And you can give it a little bit of hints and stuff, but it'll generate tests for you for your inputs and outputs. All right, so the idea is if you define your types well, your test framework can be automatically generated. That's cool. I'm gonna have to look into it. I always loved that in Haskell. All right, I spilt a little coffee here, so I'm sorry if my camera is wiggling around and stuff, because I'm trying to wipe it up and I keep going a little bit more. Okay. All right, we got to do some monkeys. Rather than trying to do it a super simple way, I'm gonna go ahead and model these monkeys a bit here. And so I'm gonna use a class monkey. Oh, not an assembly file. No, stop. Oh no, is my C button starting to fail? I'm gonna be really sad if my C button starts failing. My keyboard's expensive. I have a Kinesis. I have carpal tunnel, so I have this crazy keyboard. All right, so public class monkey. Maybe I should use record types. I don't know, but they have inside of them, they're gonna have this list. Private list of int items. So I'm pretty sure if I do private fields in them anyway, the equality check fails regardless, unless I write my own equality check. I know it can still be a record, but the maybe should we always start at, I guess it makes sense because you get a better at the very least you get a better toString, right? You get a slightly better toString if we have some properties. All right, so the things that don't change is our divisor. Is that the right word for the thing that you're dividing by? Int a true index and an int false. I'll do it false index. So we need to know our true index and our false index. You know what? You were right, Smab. You were right. The only thing that really needs to be mutable is this list. And I guess the list really isn't mutable, but the contents are, and I don't want to expose the contents. And then we have an operator. So we'll go with it's going to take in a func from an int to an int. And this will be called our operator. Okay. So now they won't have a good equality check. That's okay. And then I guess we take in sort of our initial items. The number of things a monkey takes is annoying. So if I was engineering this, I'd probably have a monkey builder that would let me sort of nicely build this and then give back some values. And then have like a build method. But that's okay. We're not going to worry too much about it. Let's have it list int. Well, the list still is mutable. The list is still mutable. You can still add and remove things to the list. The list itself is not mutable. I can't change a reference, but the contents of the list are items. Start items. So we'll make a copy of that. Okay. So we have that. And we need to be able to do sort of a throw method. Let's see. We need to public void inspect item, and this will return a bool telling us whether or not we are done. It's gonna if and this is gonna have to take in, I'm gonna keep my monkeys in a list, I suppose. List monkey. We'll call this our friends. If our items.count is 0. Ooh, maybe we shouldn't use a list. We're going to be adding and removing stuff from it. From the front. I'm going to change this to a queue. Alright, and then I don't even have to turn it into a copy here. So we have our items queue. So for item 0, we return false. Otherwise, we do new value is equal to, oh, we got to take that int item equals items. Let's try and do good practice here. We'll do this dot items dot dequeue. And then we will inspect it. So we perform our operation. So we're going to do int new val is item times, I guess if to be consistent here, let's call this old val. So we got our old val time operator op.invoke old val divided by 3, and then we actually throw it to another monkey. So we'll throw it to, ooh, we got a chest divisibility. So if so we'll do ix is going to be new val is divisible by divisor If it is, we're gonna go to true IX, otherwise false IX. Equals 0. If that's the case, and then we just say we need a, we'll return true here at the end. We need to have a way to accept public void add item, and we're gonna take in an int item, and we just add it to our queue. It's gonna be items dot in queue item. Okay. Oh, I don't even need that because I'm inside of here. So actually, I don't need an add item. I have access to it right here, so I can actually do what was it? Get our monkey. So our friends at IX dot items dot in queue new val. Okay, so that's a single inspection. We have to count, so we'll also have a public int inspection count, get private set equals 0, and we'll increment that here. Inspection count gets increased. Okay, I'm feeling good about that. My monkey type here. I need to pause just for a second. I have to go do something. I will be right back. I apologize, but I will be back in just a moment. All right, we are back here. I apologize for the dead air. My dog needed me. He was real sad. My partner, she's traveling, and so he woke up and no one was here, so he was worried. You model the data, then parse the input into that model right away. Yeah, so I have this thing here. I'm gonna go ahead and, I mean, now I need to parse it in, but I think this is essentially it as far as this problem's concerned. It's part one. I'm assuming part two, there's gonna be something a lot trickier. Ah, yeah. So it, this is just where my brain went. This is just where my brain went. But we're gonna write a parser now. This input type, um, interesting, interesting, but it should be fine. Parts, parts. Public static, monkey parse, and this is gonna take in, I guess it has to take in a string array of rows. Although I could, if I split my input on this, it'd be nice to be able to just have this as one chunk of string to parse here. Try parse. Let's see, how am I gonna transform this? Let's see. Let's get an example file. Example. Like that. Let's load this in. String. Well, I think I want to not get it all at once. Yeah, that's what I'm thinking. I'm gonna, ooh, that's smart. Split on 2 new lines. That's nice. I was gonna try and split on this blank line here. So that makes sense. String array, monkeys. Monkeys like that with an S? It's not monkeys, is it? Equals file.read all text, and then this is the first one I feel like I've had to do something like that. All right, let's see what that is, and then we will do for each string s in monkeys, just to make sure it's split the way we want. Thank you for the suggestion, Coding Cafe. I really appreciate that. Otherwise, I would have hemmed and hawed about how I was gonna do it. Or for several minutes. Oh, my example input's not in that folder. Yeah. Okay, cool. And then I'll split that into chunks. So an individual monkey, I can parse in an individual monkey that way. Cool. So we have a monkey. We're gonna parse in a single monkey. Public monkey, public static monkey parse. We're gonna take in a string monkey info. Oh, monkey info. And we're gonna split it into rows. String rows equals monkey info dot split on new lines. I'm not going to worry about the index. We're going to start with the starting item there. So we're going to get those out. We're going to get the start items. So list start items. Start items. It's equal to the second row. Split. Just a regular split. And then we're going to keep where, ooh, that comma makes me sad. I was gonna split it there and then just parse them in. right, let's split on the colon and take the second part. And then we will split on the comma. And then we will parse them in. Int dot parse. And then to string. To list. All right. So we're splitting on the colon. Then then taking this piece, we're splitting on the comma, and then we're pulling that in. Okay. For the operation, this is a little bit trickier, so I'm going to write a little helper here. Op. We're gonna do parse operator. And it's gonna take in our rows, the third line there. And public static. It's gonna return a function from an int to an int. Parse operator. String input. And I'm gonna go a step further here. I'm actually gonna split on an equals and return the right hand side. So we're actually only gonna get this chunk here. And so now I can, I can even split on old. If I split on old, then I'll get just this part here. Yeah. We'll split on old. And we'll take the second part and trim it. Yeah, and then we'll have two tokens. All right, so then we have a string array tokens is equal to input dot split, and we need to select, yeah. So then return tokens of 0. Yeah, they're multiplications and additions, right? So if I split on old, I get the right side. Is that not? Oh, I can have old times old. Gotcha. Thank you. I appreciate that. That would have made me sad. All right, so we're gonna split on that. Then we still can do the tokens. Can it be any expression on the right side? Does it have to have old? Is old always going to appear on the right side? Old. Well, let's go look at my input. I'm going to assume old will always appear on the right side. Yeah, old always appears on the right side. Okay. So in that case, it's going to be old plus or multiplied by something, which can be old. Okay, so split on the equals, and now we have our tokens. We have 3 tokens, and we want to inspect the second token. Coding Cafe saving me. I appreciate that very much. So if we are a multiplication, all right, we're gonna do tokens of 2 there as well. So if we happen to have old, we are going to get a function that is our old, and it's going to return old times old. Okay, I went much more old school for my parsing, simple character positioning. Yeah, that might have been simpler than this. All right, and then if we don't have old there, we're gonna assume it's a number. And we'll do old times int parse tokens of 2. And part of me doesn't like that I'm reparsing this every time, but I don't think that's a horrible inefficiency. It would probably be much better. It'd be we do less parsing. Otherwise, throw new exception, could not parse operator input. I always do that. Always try and put a semicolon there in my matchings like that. All right, so we parse the operator. Then we have to parse our test. It's always divisible test, right? Yeah. So divisible by, and then it's the last thing there. So we will say int divisor equals, we're just gonna get the last element, so it'd be rows of 3 dot split by 1 int dot parse like that. And then we have a true and a false. So int true ix is going to be similar to this. We're going to split on the word monkey. And this is row 4. And this is row 5. True ix, false ix. Oops. And then we'll return a monkey that has start items, op, divisor, true ix, false ix. New monkey. Okay, let's try our parse here. For each monkey, let's try making a monkey m equals monkey dot parse monkey console dot write line m. Just a quick test here. Give us a little bit of confidence that it is working. Start items is a collection. Op is that. Divisor 23. Let's get our example. 23. True ix is 2. False is 3, and we have no inspections. Okay. I think that I am feeling pretty confident that that worked. All right, with our monkeys, now we just gotta throw it around. So we're going to do a list of monkey friends is equal to monkeys dot select monkey dot parse. So we're gonna parse all our monkeys, turn them to a list, and then we'll do a round. And around, we'll take in a list of monkey friends. And we start at the first monkey, and we say, for each monkey m in friends, while m dot inspect item and that. Oh, and we have to give it to friends. I think that's it. So it's just going to do an inspect item, and it's going to just keep. Eventually, when there's nothing left to inspect, this returns false. And then at the end, we need to get the monkeys that have the largest. So that's 1 round. That'll do 1 round. Okay. And so we will say int round equals 0. Or we'll do a for loop. For int round equals 0. Round less than 20. Round plus plus. Round friends. And then we need to inspect that list. So we want to find the 2 monkeys that have the highest number of inspections. So friends dot order by, and given 2 monkeys, right? Yeah, can I just say monkey goes to m dot inspection count? What does that say? Dot list, get that back as a list. The to list, but does not have a value. List monkey ordered. And then let's print these out just so I can see them. Because I think this is going to order ascending, not descending. But just so I can get an idea, for each monkey m in ordered, console.writeLine m. Oh, and now I don't have an ID from. Let's create an ID just so that I have that. So we'll have a public int ID. We'll make this a get, and we'll have a private static int next ID 0. It's next ID plus plus. All right, so we should get their IDs back. Let's see. Let's print them before we sort them. Friends, come on, friends. Be a little easier for me to look at if they're in order, and then look at them again unordered. So monkey 0 has 101, 95, 7, 105, and then it ordered them in reverse order. Can I tell order by? Let's look at order by. Ascending, descending, sorts the elements in descending according to a key. Oh, I need to look at this one. Order by descending. All right, cool. Order by descending. And then we'll just look at the first 2. Int m0 int monkey business is equal to ordered of 0 dot inspection count times ordered of 1 times inspection dot inspection count. Console dot writeLine total monkey. Where is that? Total monkey business. Monkey business, like so. And I can get rid of that. I don't need to print them out. All right. Oh, that's not. That's about to paste that in there. All right, let's get my input. I have some confidence here that I'm gonna be okay. New file input. Do with our input here. Yeah, no problem. No problem. Do you now have immutable lists? All right, let's try it. 120,000 monkey business. All right, 1 gold star. Let's see part 2. Coding Cafe has me worried that part 2 is going to be tricky. 1 gold star. Thank you, Smab, for that beautiful gold star. Okay. You were worried you might not ever get your items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Well, that's annoying. Unfortunately, that relief was all that was keeping your worry levels from reaching ridiculous levels. Yeah, you'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. These new rules, you can still figure out the monkey business after 10,000 rounds using the same example above. All right, but we're no longer dividing by 3. After 10,000 rounds, the 2 most active monkeys inspected items this many times and that many times. Okay, multiplying these together, the level of monkey business is, in this situation, is this much. Worry levels are no longer divided by 3 after each item is inspected. You need to find another way to keep your worry levels manageable. So we probably got to find like a factor and do modulus. All right, so the factor, this is probably like a greatest common denominator type problem. So this one's tricky because you just have to know that you could, I could see students thinking, oh, well, I'm just going to switch to a big integer and then your problem will never finish before, maybe it'll finish eventually, but probably too big to finish before the heat death of the universe. But I'm imagining there's a modulus trick here where we just need to mod. Well, we're no longer dividing by 3. But we're gonna do the greatest common denominator, I suppose, to figure out if we're divisible. I just gotta remember exactly what that means. So yeah, we just gotta do a greatest common denominator thing and do some modulus trick. All right, so let me wrap this as part 1. Yeah, Python promotes to big int. I made the modification first, and after 800 iterations, it was really slow. Yeah, I imagine it just blows up. So you want to just keep modding it, I think. I can't. I know that there's going to be a trick to it. I might have to go look at how to do it again. But I know this is just like, it's either greatest common denominator or lowest common divisor. Are those the same thing? But yeah, big int will kill you as these get giant. Let's see if I can figure it out on my own first. We'll switch back to the example. And we're gonna wrap this as part 1. All right, void part 1 is this thing here. And I need to modify my monkey slightly. For the divisor, I want there to be, the easy thing would be to just make all the monkeys have a divisor of 1, so you divide by 1, but the new val Yeah, so that's I really need to make sure part one doesn't break my setup. Ooh, Smab, that's a sad. What a horrible, annoying bug to have. All right, so the greatest common denominator of something here. So I need to divide or mod by. So I have my new val. All right, all right. We're gonna make a subclass. Is that what we want? We want a subclass called Mean Monkey. Is that how I want to do it? I'm trying to think without destroying my part one, which has this divide by 3. I need a different way to get this, but I only want to swap out this one thing. So I think I'm just gonna create a new subclass. So I want to add in let's see here. Public abstract record. And then we're gonna have 2 subclasses. New file, nice monkey. Public record, nice monkey. Gonna extend monkey. And it is going to take in all of the same things. Is that how I do that? How do I make my... Monkey does not have a base constructor. Does it have to take in... So if I want... Can I make... Oh, I really want my monkey. Monkey does not contain a constructor that takes 0 argument. Alright, we'll do a hack because I don't want to deal with that right now. We'll do a hack. I want to have a function public bool inspect. We'll rename this nice inspect item. What does my brain want me to do? This is where I hem and haw. I'm trying to think, how do I want to do this? Not too bad. I need a different inspect item, but the only thing I care about is this being different. So I'm going to write a method. Nice new val. Int old val. Return. And then the idea is I swap that out. With my idea was I swapped it out with a subclass. You won't be surprised to know that my solution to this issue was old school. Yeah. So the part 1 and part 2 is an interesting thing about having a code. I don't, so I don't want to copy and paste. Really, I just want to be able to tell this. I want a different. I want to create a subclass, really, where I just have this thing called new val, and this happens to be a protected virtual method that I'll have a subclass of monkey. Yeah, that's what I was thinking. I was thinking I would do this, and then the hint is, well, I mean, I think I just need to calculate a divisor. No, you're fine. You're fine. Um, yeah. So I guess we'll be lame. Um, or um, yeah, we'll pass in a bool. Really, really, I want to do a subclass. I want to do a subclass, but I don't. Let's do a new file. Mean monkey. Can my mean monkey? I want to extend this, but I can't. I can't extend monkey, can I? Or do I have to do monkey? I just don't know the syntax here. And is this only a single record? Mean monkey. Hey, there we go. Look at that horrible. Oh, that didn't do what I wanted. It's not connecting a structure that takes 10 arguments. What's the syntax here? Record subclass C#. Let's take a look. Let's take a look. I'm close. I just can't. I rarely do this type of subclassing. Sub. Yeah. So the idea though is my inspect is the exact same thing. The only thing that's different is going to be the new value. The only thing that's different, so I'm going to write a protected method new value that you overwrite in your subclass, and that's the only thing that matters. I just have to figure. I don't know how to do the syntax for subclassing. Record subclass C#. Record that. Student. Oh, I'm dumb. I'm dumb. All right. Of course. Yeah. So now my subclass, I just override this. So my mean monkey, protected, override new val like that, and then all I have to do is override that, and then when I parse, I'm gonna have a mean monkey parse, or I'm just gonna have actually, here even better. I'm gonna have this take in a monkey to convert, and we're gonna convert our monkey to a mean monkey. There we go. All right. So to make a mean monkey, you just pass them into this mean monkey converter, and you get a mean monkey. And now we have this code here. And we gotta mod by something. I can't. I might cheat a little bit and look up. I know I have to mod something, and my math. I'm pretty strong in math. Sometimes, but I don't do this type of stuff all the time. I think I just need a mod by all of my multiples. Anytime I multiply, that's the issue. Let me hard code that real quick just to check. If I did 19 times old and mod by that, is that my greatest common denominator? 19 times old. Ooh, that's interesting. That's interesting here. I might have to, I think I'm gonna cheat a little bit here. I know what I'm supposed to do, I just can't remember the exact math. So don't, I hope no one's too disappointed in me. But I think I gotta cheat here a little bit just to know exactly what I need to mod by. Gotcha. Yeah, so I'm kind of a math nerd, but yeah, I'm kind of a math nerd. I'm gonna cheat a little bit here. You're disappointed in me. Oh, maybe I won't do it then. I just don't know what I'm supposed to mod by. I know I got a mod. I'm not, I can't. You guys want to watch me sit here with a piece of paper and work out the math of how to keep the divisibility? All right. So the idea here. Oh, it's by these. It's by these divisors. I know I'm on the right track. I want on stream. I don't want to sit here. So I have a piece of paper here. If I wasn't on stream, I'd sit here with my little notebook, and I would figure out what I need to divide by. But I feel like that's not interesting to watch, is it? But my divisible by 23. So okay. So to get all right. Let me work it out. If I divide by 23, I need to see if this thing's divisible by 23. And then if it is, it's gonna be one of these two things. And the monkey I pass it to is gonna do something with it that has to manage that divisibility. So it's sort of like dealing with prime numbers, kind of. Oh, are all of these prime numbers? Oh, this is like encryption. 17, 7, 13, 2, 19, 3, 5, 11. Do we... All right, so these are all prime numbers. So I just need to mod by the greatest common divisor of these. Okay, so I need to calculate my greatest common divisor. And then I should be able to just divide by that. I think. Yeah, okay. All right, thank you for being disappointed in me and making me think through this. So I need to get all of my divisors here. Okay. Yeah, so I just need to multiply them all together, right? And then that becomes the thing that I think I just mod by that. Is that right? I either mod by it or I divide by it. So let's see here. Yeah, so they're all prime, so I'm happy with that. And I guess I'll pass it in there. To make a mean monk, we need to know what our GCD is. Think that's what it is. Or is it what lowest common multiple or greatest common GCD versus LCM? The least common multiple of 2 integers is the smallest positive integer that is a multiple of both. 2 integers is the largest positive integer divisible by both. All right. They're related. They're like inversely related or something like that. Okay. So for part 2, void part 2, I got to int LCM actually, because Lowest common multiple? I don't know. I don't know. We'll be crazy here. Monkeys, and we're gonna, yeah, monkeys dot select monkey dot parse to list. All right, we'll get our monkeys first. So we have our lists monkey friends, Byron's friends. So we have our new monkey friends here, and then we want to int. I think it's LCM. I don't know. Don't be too upset with me for my lack of naming these properly. Friends dot select m dot divisor, and then is there a product? No, there's not a product. I want to multiply these together. They're not a product? I'm surprised. All right, well, aggregate. And ag. Our seed, actually. So the one I want is one that has a seed. Or I just want to multiply them together. A, B goes to A times B. Can I do that? Dot. Yeah. With the LCM or GCD, you mean? I guess that makes sense. Lowest, or I'm just when you went with the short form as others reading the code. When I'm saying LCM, yeah, you're saying the short form is I'm calling it LCM. And then I need to convert all my friends. Only if you know what lowest common multiple is, right, Gupta? Yeah, so you have to have seen that before. I guess if you Googled it, it would make sense. I have, back when I was in probably in undergrad in discrete math, we probably had to do like greatest common divisor type stuff. Okay, and then we are gonna do list of mean monkey. Mean enemies. We're gonna call these ones our enemies. And we're gonna do friends.select new mean monkey. It's gonna take in, oh, I can't quite do it, M and our LCM here. Dot to list. Okay. Then we have to do 10,000 rounds. Did I do this right yet? I called it GCD here. Let's rename this LCM. Oh, it didn't like that rename. Now we're gonna do it 10,000 times on our enemies. Ooh, that's interesting. It's telling me that enemies. That's interesting because. All right, well, we'll make this just a list of monkey then. Can we do that? Doesn't mean monkey extend monkey? Why can't I do that? I'm a little confused why the types there don't like it. Cannot convert from mean monkey to monkey. Monkey m equals new mean monkey. Friends 0, 1. I can do that. Well, the monkey is the parent type, isn't it? I should be able to do this. So I'm just confused. why I'm gonna try something here. All right, list of monkey enemies equals a new list. This is interesting to me. For each monkey F M in friends, monkey doesn't like that. Call this friend. The I should be able to. Yeah, so that was just interesting to me that I couldn't. The link wouldn't let me do that. Link was not having it. I can do it this way though. Enemies.add. Yeah, that's what that I'd have to cast it. Okay. That's just come on type system. Let us do let's go back here. I want to do friends dot select M goes to new mean monkey M LCM, and then I have to cast this to a monkey here. Dot to list. Okay, I can do it that way. Oh, there's an as keyword. New monkey, and I can do as monkey. Hey, I like that so much better. I learned something new. Thank you, Smab. All right, and let's see if part 2 works out for me. Thank you guys for encouraging me not to cheat. So I was gonna go look it up when I could still be wrong here. Total monkey business is 0. Well, that's not right. Why did I? Yeah, I fixed the round thing. Oh, my aggregator. I have to give it a 1. I thought it would just start at the... No. What is my console? LCM. The LCM must be 0. No, it's not. It's not. All right, let's... Oh, because I'm using my friends here. Yeah, I was ordering the original list, and so they all had 0. If it was 0, you would mod it. If it was 0 and you mod it, would give div by 0 error. Well, this is clearly not working. Let us... we are getting too big somehow? which I don't quite get. I'm gonna have to do some. This is where, like, I wish I had a unit test. Well, it shouldn't. So here's the thing. Oh, well, yeah, let's see here. I am incrementing. You're right. You're right. For my actual monkey business, my actual monkey business needs to be bigger. Thank you. I was about to go down a rabbit hole of sadness, I think. Let's try making this a long. And then let's change inspect count to a long. Thank you, Coden Cafe, for... I knew I was getting an overflow. Oh, bollocks. Here we go. I still have something wrong here. Because this number is incorrect. Let's take a look here at... I want to see where this, so after round 1 this should work. I want to see, I want to do the inspections at these points to give myself a little bit more confidence here. So we're gonna pull out that information and we're gonna say if after round 1, yeah, so if round is, let's do this just so my rounds are easier to manage. If round is equal to, oh, I can just do it at the beginning. I like this better. So we're gonna look at if round is equal to 1, display info on my enemies. And we'll do a deploy display info list of monkeys. Black Valhalla. Let's I can never remember how to moderate. How do I moderate? Usually I get like a trash can icon next to it. I'm just not wide enough. That's okay. I would like to moderate you. That's okay. We'll ignore that person. Yeah, if it's writing unit test, it'd be much easier. I won't worry about it right now. It's not, this is annoying, but isn't anything that I can't handle. I did it the last time. I always get those. Usually there's like a little trash can icon that shows up for me. I don't know why I'm not getting that today. Yeah, you're probably right. Show mod icons. I reset my cookies. There it is. Ban this user. Okay. There we go. Thank you, Gupta. Display info. I want it to do this. So we are gonna do for each monkey m in monkeys. Console.writeLine. Still this. And monkey m.id inspected items m.inspection count. All right. 20 round equals 20. And we'll print out the round on console.writeLine after round 20 or round equals 1000. So we'll start there. It's almost certainly going to be off right away. Oh. Round 1 is fine. Round 20, something went wrong already. Okay, so I'm starting to get off on round 20. So I'm gonna have to, it should match. Gupta had the same 9 instead of 8. All right, I have something on. You had an intermediate overflow. Oh. So if I just that's so annoying. All right, let's do it. Thank you for the hint. Otherwise I might be here all day. Oh, can I do this? Int long. Eric gets us. That was weird. I want to do int with long. All right, and ix. All right, this one can't be. This will be back to an end. Let's see here. All right, my search and replace did not work how I wanted it to, but there's only one thing if I think about it. Maybe I should, but maybe I don't need to. And that doesn't need to be long. All right, let's see here. .NET run project solution. Change this to a long. Hang on. Oh, I need to go. I've broken all of my stuff here. Cannot convert int to long. This should be an int. Cannot implicitly. Okay. All right. Well, divisor. I've made my life much harder than it needs to be. This was a mistake. This was a mistake. This has to be riveting to watch. Okay. Bring that back up. God. Intermediate overflow. Okay. All right. All right. Maybe we got it. Go on, coming out. Whew. This is not what this part 2 here. Part 2, my students won't be able to handle this. I don't think, maybe like 2 or 3 of my older students can do it without me just giving it away to them. And I have my input here. I kind of knew what I needed to do. All right. Yeah, Gupta. I am a computer science teacher for. I work at a school that is. I teach students ages like 7 to 18-ish, 7 to 17. My oldest students are 18. I also do tutoring of college, university level students. We've been doing advent of code I think they're on day 7. They're on day 7. I've been putting together videos to help them get through it. I've been doing my videos in C#. Not all of them are using C#, so they can't just copy my code. Yeah, computer programming. We've been doing it for all of them. My youngest student that's doing it is 9 years old. He's doing awesome. It's amazing. But Smab, let's take a look at yours. But yeah, this is the first puzzle where the part 2 is so different. It's not programming problem, right? It's a mathematical problem. This is the first one. Yeah. So it's a good excuse for my older students for us to talk about the first part. My young students do, but the second part. So I've been creating tutorials for the first part of each puzzle, and then sort of leaving it to them to figure out how to do the second part, or try to develop a strategy for the second part as a class and working together. The mod stuff, my older students, I have a couple students who will be fine with it. They'll be able to figure it out. So it depends. Every term's a little bit different, but sometimes I teach algorithms like what you would consider like a first or like a second year. My older students take an algorithms class. We do the Princeton Java algorithms course. And so we get through the first part of that throughout the year, and it works fantastic. I'd say some of my students graduate high school with almost an entire undergrad of computer science under their belt. All right, let's check this out. Smab, thank you for sharing. This is cool. Let's see here. So we got part 1. All right, so you have some solution and you tell it how many rounds to run. That's nice. And then this one here must be that this must be your trick that tells it not to divide by 3. Let me know if that's true. Let's go look at that solution. Number of rounds. If it is part 1, number of rounds equals 20. Interesting. We get a monkey list. We modulo. Okay, so this is your lowest common multiple. And then we loop through our monkeys. This is a little confusing to me because I think catch makes me think of a throwing exceptions. So at first I thought maybe there was some, at a glance I thought you were catching exceptions in here, but I guess catch makes sense. So you get the item to throw, and then the other monkey catches it. Gotcha. Oh, I'm dumb. Thank you for pointing that out. I'm dumb. This, at a glance, this looked like you were setting the number of rounds to 20. I don't know why. It's early. I got that 6:30 a.m. brain craft. All right, let's keep going here. So we loop to the number of rounds for each monkey and monkey. We do their inspection, and then we throw it. Or we catch it is what we're doing here. And then we order by take two aggregate. I like that. I need to get better with this link stuff, because this is just this tickles my my functional programmer brain. I'm like, oh yeah, this is exactly what I would want to do in Haskell, right? All right, so then let's look at our monkey type. Name, operation, divisible by, true monkey, false monkey. Gotta watch out for those false monkeys. The variable names on this puzzle crack me up. Okay, so inspect. Okay, so your inspect goes through creates an IEnumerable that goes through all of your items, yielding them out, and then we update. We have a method update worry. Okay, I like that. I like that. And then your Boolean here. This is how you say, okay, whether or not you divide by 3. It's a nice little hack. I'd call that a nice little hack. Worry level mod divisible by equals 0. Worry level divisible by. Where does... Oh, that makes sense. Again, like my morning brain is killing me a little bit here. Yeah, if it's divisible by that, we do it. Oh yeah, I guess you can do the moduli in there no matter what. Well, so yeah. So this is why I'm curious whether or not you can do this for Prop 1. Maybe you, I'm not sure you can. If one of your input numbers happen to be 3, I think you could. Is one of the input numbers 3 in the original puzzle? 7, 13, 19, 23. No. Interesting. Anyway, this was something that was interesting to me. Although, on the first puzzle, I bet modulo is 1. No, that wouldn't work either. I don't know. I'm curious about that as well. You know what it is that these numbers don't get big enough. That's what it's going to be. These numbers don't get big enough for the modulo to matter, is my guess. Because when we looked at my modulo was this giant number. So your numbers just don't get big enough on the part 1 for it to matter. That's exactly what's happening here. So yeah. That makes sense. All right, so it works. Again, I looked at that and I was also confused. All right. Catch. I almost wrote this method. I ended up not writing this method. I mean, incorrect is a you could this could be a bug, right? This is nice. What does, this is something I haven't seen. What does this do? Is this saying Smab, what does the caret 1 do inside of our substring? One from the end. That's nice little syntax cut. Oh, I like that. I'm gonna use that in the future. I have always done like a yeah, so in like Python or something, you can do like the minus something there. I like that. Cool. Somehow I've highlighted, or GitHub wants to highlight these dots for us. And then item, calculate, operation. This is a nice little solution you got here, Smab. Thank you for sharing it. I like that you're doing everything with these IEnumerables so they work nicely with our link stuff. I really like that. And then this cracks me up a little bit. I almost did it, but I decided to figure it out. All right. Gupta hates parsing. Yeah, the parsing was gross. The parsing on this one was not fun. That's gonna be a whole. It'll be fun. Fun. That's gonna be a good exercise for my youngest students. All right, let's parse this in. How do we parse this? How do we parse data? They're getting really good at it. All right, Coding Cafe. Let's check out your Python solution. Thank you for bringing it. I like you like parsing, Smab. That's funny. I like building parsers. So like using parser combinators. I like parsing in like programming languages and building up abstract syntax trees. That is a fun little exercise for me. I really, really like that. Okay, here we go. Our monkey. We've got our ID, items, operator, divisor, D true, D false. Okay, so we've all essentially created the same class here, which is nice. Again, naming it throw. It hurts my soul because I keep thinking that's an exception. That's funny. Okay, so then this is gonna be our modulo. And so this is a solution just for part 2 because we have that modulo. And we're gonna update our item, mod it by our LCM, and then send to same thing I did here. So we use ternary operator to determine who we're sending it to, and then we add that to their items. Ooh, this is a clever little fix. So I ended up using a queue because I was like, well, I don't want to have to remove things. Your little, I like this and saying like, well, at the end I know my list is empty, so just empty it out. I like that. I like that. Simple, so you don't have to think about it. All right, and then here's the actual program itself. So monkeys is empty. We open up our this is essentially parsing, I'm assuming. What is this? I'm not super, I did a lot of work in Python. Okay, so you're just piping in a file then. Okay, open 0. You're piping in the you're specifying, yeah, cool. And so we're building an iterator on our input. Gotcha. And then we're gonna take each of our lines here. Yeah. Convert it to an int. The last, ooh, this is clever. Cause you're okay. I like that. That's a nice little clever trick you did there. Okay. This gets the last int on each line. And then we can say that our index is that, our items is that. So we parse this in here. Yeah, Smab, I'm noticing that. This is what I was saying, in Python they have nice syntax for that. You just put a negative number. I was like, Python, I love a lot of the niceties Python provides. I had a program in Python I worked at a company for 4 years where we did Python, Haskell, and C on the back end. But Python was it was like a Flask application, and you'd often build these, we're doing machine learning stuff, so we ended up building some custom machine learning stuff in Haskell. Actually, a little bit of OCaml. We used some Jane Street OCaml stuff. But anyway, my Python is a bit rusty. So this is our, we parse everything in, and then we find our divisor, and then we loop over it. This is Coding Cafe, great solution here. I like this is a nice balance between very brief, a nice short solution, but also something you can read and understand. I really, really like this solution. If you were a student of mine, the only criticism I'd have would be, all right, how do you break this up into functions so that you can write tests? That's the only little thing that I would do, but this is great. This is great. Nice work. Thank you so much for sharing it. Let's go ahead, and I hope you don't mind. I'm going to follow you so I can keep track of of your progress on the advent of code. All right. All right. Cool. So I usually stream for about 2 hours. Streaming is addictive. I don't know if any of you have done it, but streaming gets addictive, and I end up not being particularly productive when I stream. And I have 10 minutes left, so I'm probably going to just end a little bit early here. Maybe chat with you guys just a bit. The delay drives me a little bit crazy, because there's like a 10-second delay. But this was fun. Thank you guys for hanging out. If you want, I usually stream, at least for the next week, I'll be streaming off probably every day around this time. So if you want to come back, if you want to get a notification, feel free to follow. I'm not in this for the follows, believe it or not. I originally was just live streaming because I think it's important for my students to see the process. And so I stream on Twitch, and then it archives it on YouTube for my students to go back and watch. But feel free to follow. I usually I've been trying to stream Monday and Wednesday outside of Advent of Code. Monday and Wednesday just working on some project. But I have been streaming pretty much every day in the morning, my time. Wake up in code is what I do. Wake up in code, get my brain working, smash my face against some of these problems. But yeah, thank you for the follows, and thank you for hanging out. It was really, really fun chatting with all of you. And of course, as always, what I say is keep coding, keep growing, have a beautiful day, and you're welcome back anytime. Smab, I'm in United States, Arizona. So I'm in the southwestern part of the United States, Arizona. I get up at like 4 in the morning. That's just when I wake up. I don't need an alarm. It is 6:45 a.m. right now. But yeah, I live in Arizona. The desert, beautiful, the most beautiful place I've ever lived. I've lived in New Mexico. I've lived in Massachusetts, Connecticut, and California. Those are the places I've lived. I lived in Los Angeles for 2 years. I did not like Los Angeles. I know, it's my audience. So that's why I said I didn't think anyone would ever be watching these. I was mostly streaming so that way my students could watch it later on to see my thought process. Because one of the things that's really important for young students to understand is you don't just come up, your solution just doesn't happen. You don't always end up with your solution right at the end. There's a whole thinking process that takes a lot of time to develop. And so my students, especially my young students, get frustrated that I just don't know what to do. I just don't know how to get started. And so I like to have, in class, I try and give them at least half the time in class. I don't lecture a lot. I do projects usually, but I try to have them programming a lot in class. And then if they're not programming, we're doing live coding and doing live shares. So we're working in the same document together, like as a class, doing a class coding. Worked for an American company and used to travel for a couple times a year. Arizona, I gotta say, is gorgeous. I'm in the southern part of Arizona, which is nice. I've been to the Grand Canyon several times when I was growing up. I still like to hike a lot. I haven't done it as much as older, but I used to love go camping. And so I was in New Mexico, and I was in Scouts. And so not every year, but frequently, we would go to the Grand Canyon. The Grand Canyon is so awesome in the spring before it's hot. And we would camp. It'd be a week-long trip usually. We would camp on the south side of the canyon, and then we'd do a hiking trip where we hike down into the canyon, you camp one night in the canyon, then you hike up the other side to the North Ridge, and then there's a little airplane you take back to the other side. It was really cool. One of my friends, their dad was a pilot, and so he would fly us back. Really, really cool. Some of the most memorable trips I had are the Grand Canyon. But yeah, my students are really, really digging the um, the advent of code. Like I said, their homework was to try and finish day 7 over the weekend. So we've done days 1 through 6. Pretty much all of them have finished days 1 through 6. The stack one was a really challenging parsing one for some of them. But aside from that, it mostly just went through it. I try and give them a nice structure so that they'll be able to solve the second part without too much difficulty. But this one, no problem. Not as bad. Well, so I knew what I had this idea of what I needed to do. Thank you, Smab, for being so disappointed in me that you shamed me into thinking through the problem. Well, I thought I was gonna have to calculate like a greatest common divisor, but because they were all prime numbers, it made it easier. So I liked that. Alrighty, and I'll say it again. I hope everyone here is having fun. You guys have made this a wonderful morning for me, so thank you for hanging out. Thank you for catching my bugs for me. That's one of the best things about live coding. And I hope you'll come back next time. I hope we'll see you again soon. Have a beautiful day.